This problem might be one of the easiest problem 12s I've ever seen on an AMC. So we just want to find the sum of the roots of this equation that have a positive real part. Now let's simplify this equation. Z to the 12th equals 2 to the 6th, and I'm not even going to worry about the 2 to the 6th part. I'm just going to worry about, let's just say Z to the 12th equals 1, and then we can multiply by like square root 2 later. And the reason I'm going to do this is, well, Z to the 12th equals 1 implies that Z is a 12th root of unity. So I'm just going to write these like e to the I theta. And so, I mean, I guess we don't even have to write them this way, but there's 12 such e to the I thetas that are 12 roots of unity, such that e to the I theta to the 12th is going to equal 1. And so putting them on a unit circle, where this is going to be the real number axis, this is the imaginary axis. So putting them on a unit circle, each of these 12 is going to be like 30 degrees apart, because that's 360 divided by 12 is 30. So each of these 12 roots are 30 degrees apart. So that's a root right here. There's a root here at 0. I guess this is like the actual like number 1, that's a root. There's a root 30 here, there's a root 60 here, there's a root 60 here. Now notice that 90 and anything on this side don't really count, because these are going to have negative real parts, or I guess this one is going to be 0, these two are 0, and all of these ones are going to be negative. So we only actually care about these 1, 2, 3, 4, well, 1, 2, 3, 4, 5, I can't count today, but these 5 roots on this right side. So we just want to find the sum of these 5 roots of unity, and this is just some common application of like the unit circle right here. So this one is this is a 60-degree angle. So this one has coordinates. How about we'll just write it in terms of complex numbers, not coordinates. So this one is going to have coordinates 1/2 plus square root 3 over 2i. This one right here is going to have coordinates square root 3 over 2 plus 1/2 I. This one over here is just 1, because that's the real number. And this one has, on the bottom here, we can notice that this is actually like the opposite of this. This is the complex conjugate of this. So this actually has 1/2, or not 1/2, this is square root 3 over 2 plus, or minus 1/2 I. So square root 3 over 2 minus 1/2 I. That's this one, it's the complex conjugate. And similarly, this one is the complex conjugate of this one, so this one is going to be 1/2 minus square root 3 over 2i. Now the nice thing is that all the i's cancel when we add these up. So that's a good thing. Now we just want to add up the remaining. So, well, this 1/2 plus 1/2 is 1. Then we have 1 plus, well, these two, square root 3 over 2, square root 3 over 2, that's a square root 3. And then this one, can't forget about this guy, so that's that. And summing this, we get 2 plus square root 3. That's the sum of the real parts, but we're not done, because I have to multiply by square root 2, because that's technically the factor, because a complex number is, in polar form, is r e to the I theta, and I kind of just ignored that r part until now. And so the r, that's just the magnitude, and the magnitude of these, well, if the magnitude of something to the 12th power equals 2 to the 6th power, then this magnitude is going to equal the square root of 2, because, well, square root of 2 to the 6th power or square root of 2 to the 12th power equals 2 to the 6th, which equals 64. So the magnitude is square root of 2. So that's the r part. And so now I'm just going to multiply all of this by this magnitude. And the reason we can do this is basically just the distributive property, or the distributive like theorem, I guess, because technically these are each like 1/2 or root 2 times this. This is root 2 times this. And so I'm sort of just like factoring out that root 2, then summing these, and then I'm going to multiply it back. So that's just distributive property. And so this is the final answer. So this is just 2 root 2 plus root 6. That's their answer right there. And that is this one. So pretty easy problem, just a trivial application of like the unit circle and roots of unity.